All right, let's get into it. We're going to pull back the curtain on one of the most common, and maybe one of the most misunderstood, features in all of Windows. Yep, I'm talking about that little box that pops up asking for your permission. Today, we're doing a deep dive on user account control.
Oh, you know the one. You're just about to install some new software, or maybe you're digging into system settings, and bam, the whole screen dims, and this little box shows up asking if you really want to let this app make changes. For most of us, it's just this little speed bump we click yes on without even thinking.
But have you ever actually stopped to wonder what's going on behind the scenes? What complex machinery kicks into gear the second you give it the green light? Because, well, it's not just a simple "Are you sure?" button. It's actually the final move in a pretty sophisticated security dance designed to keep your computer safe. And that's exactly what we're going to break down. So, the entire philosophy behind UAC, the big idea, is built on this core security concept, the principle of least privilege. It's a simple but really powerful idea. It basically says that any program, and even you, the user, should only have the bare minimum permissions needed to get a job done. Nothing more. This seriously cuts down the damage if something goes wrong, like if you accidentally click on some malware. And here's the really clever part. When you log into Windows as an administrator, it doesn't just hand you the keys to the entire kingdom. Nope! Instead, it creates two different security tokens for you. Think of them like key cards. First, you get what's called a filtered admin token. That's your daily key card. It lets you do all your normal stuff, but all the super powerful admin rights have been stripped out. And then, kept separately, is the full admin token. That's the master key. It has all the power. You don't just carry the master key around all day, right? You only use it when you absolutely have to.
This whole setup, this default state you're in, it actually has a name: Admin Approval Mode. It's the system that forces every single application you launch to use that less powerful daily keycard by default. It's Windows' way of making sure you're always operating with the least privilege possible, even when you're logged in as an admin.
Okay, so that brings up a pretty obvious question, right? If everything starts out with limited power, how does a program get its hands on that master key, that full admin token, when it actually needs it to, say, install something or change a critical setting? Well, that whole process is called elevation.
And this path to getting more power is brilliantly simple. First, an app has to explicitly ask for admin rights. That's the trigger. Step 2, that request makes the UAC prompt appear, but, and this is important, it shows up on something called the secure desktop. Then you, the user, give your consent. You click yes. And only then does the final step happen. Windows starts a completely new process, and it's that new process that gets the full unfiltered admin token. The original app never gets more power, a whole new elevated one is created.
Now, that secure desktop I mentioned, it's absolutely crucial. When your screen dims, you're actually being switched to a totally separate, isolated desktop environment that your other applications can't touch. This is a massive security feature. It stops malware from drawing a fake yes button over the real one or trying to click it for you. When you're on the secure desktop, you know you're only talking to Windows itself.
So this system is great for modern apps that were designed for it. But what about all that legacy software out there? Programs written back in the Windows XP days, way before UAC was ever a thing. Those programs just assume they have admin rights and try to write files to protected folders. So how does Windows deal with them without just letting them crash and burn?
The answer is this really elegant piece of tech magic called file and registry virtualization. So instead of just blocking the old app and causing an error, Windows intercepts that attempt to write to a protected place. Then, completely behind the scenes, it redirects that action to a safe, special folder inside your own user profile. The old app has no idea. It thinks it wrote to the system folder and that everything worked perfectly, but your system's core files remain completely untouched.
This shows that little sleight of hand in action, but for the Windows registry. See, if a modern app tries to write to a protected part of the registry, it just gets a flat "access denied." End of story. But when an older, virtualized app tries to do the exact same thing, Windows steps in like a helpful traffic cop and silently reroutes that data to a personal, virtual store location for that user. The app is happy, the system is safe.
And the important thing to get here is that this happens for both files and the registry. So if an old program tries to save a configuration file to, say, the main program files folder, Windows might actually stick it in a hidden folder under your user profile instead. Same thing for the registry. If it tries to write to the main HKey_local machine key, it gets shuffled over to a virtual section under HKey_current user. It's this amazing, seamless compatibility layer that keeps old software alive without sacrificing modern security. So when you put it all together, you've got the dual token system, that secure elevation process, plus the virtualization for older apps. You start to see that UAC isn't just one thing. It's a whole multi-layered defense strategy, all designed to let us get our work done while keeping the system locked down by default. And just as a final piece of info, it's pretty helpful to know that apps themselves can actually state what kind of power they need. Developers have three main options. They can set it to as invoker, which is what most apps use. Think Notepad, it never asks for more power. Then there's highest available for tools like the registry editor, which will ask for admin rights if you have them. And finally, require administrator, which is for things like installers that just plain won't run without full admin privileges. So the next time that UAC prompt dims your screen, just remember what's actually going on. It's not a roadblock trying to annoy you. Think of it as a security checkpoint. It's the moment the operating system pauses, turns to you, and asks for your explicit permission to hand over the master key. It's designed to make sure that at the end of the day, you, and only you, are the one in control.
If you want to help me out, please smash that like button, leave a random comment, and subscribe if you want to become a better hacker.